Now for eclipses. They are special because they are rare. They are rare because the moon's orbit is tipped slightly with respect to the Earth's orbit around the sun, the ecliptic. Although the moon passes through the ecliptic plane twice every orbit, twice a month, it must do that at exactly new or full phase for there to be an eclipse. Usually the moon crosses the ecliptic plane at some other phase, so the Earth's shadow misses the moon, or the moon's shadow misses the Earth. Another factor is that the moon's orbit wobbles or precesses, so eclipse dates constantly shift with the succeeding years. For a lunar eclipse, the moon is being eclipsed or covered up, which means that it is at a full phase in the Earth's shadow. During a total lunar eclipse, the full moon is entirely within the darkest part of the Earth's shadow, the umbra. However, the full moon will have an orange-red color instead of being totally dark. That's because of the Earth's atmosphere. Sunlight passing through the atmosphere is refracted or bent toward the moon. The blues, purples, and greens are scattered away more than the yellows, oranges, and reds. So the longer wavelength redder colors make it to the moon. If you were standing on the moon looking at the Earth covering up the sun, you'd see a ring of sunset orange-red glow around the Earth. If the Earth didn't have an atmosphere, then the moon would be entirely black. For a solar eclipse, the sun is being eclipsed or covered up, which means that the moon is at a new phase and the moon's shadow is touching the Earth. Because the Earth is about 4 times greater in diameter than the moon, the Earth's umbra is much larger than the moon's umbra. That is why it is much easier for the moon to get entirely eclipsed than for a total solar eclipse to occur. Yet another factor is exaggerated in these drawings, the elliptical nature of its orbit. Sometimes the moon is closer to Earth than other times, and that closest point, or perigee point, is not correlated at all with the moon phase. In order to make a total solar eclipse, the moon must be at exactly new phase when it is crossing the ecliptic, and the moon must be near the perigee part, or the closest part of its orbit. If the moon is exactly lined up but near the apogee part of its orbit, some of the bright surface of the sun will be seen around the moon, an annulus or ring of light around the moon. So it is called an annular solar eclipse. Next slide. This slide shows some pictures of solar eclipses. The top strip is a sequence of pictures from the May 2012 annular solar eclipse that passed through Northern California and other western states. The moon and sun were lined right up, but the moon was too far away to cover up all the sun. Even with most of the sun's surface covered, it was too bright to look at, so these pictures used a solar filter. The next picture is from the August 2017's total solar eclipse that was visible in a narrow strip from the west coast to the east coast. This image is actually a composite of several different exposures to capture detail in various parts of the corona, the sun's outer atmosphere, that can only be seen when the sun's surface is covered up. During totality, the sun's corona is about as bright as a full moon, so you can look at it without a solar filter. The human eye has a much wider dynamic range than any camera, so you could see all of the details in the various parts of the corona at once. Here's a map of the total solar eclipses visible in North America during the first half of the 21st century. The next total solar eclipse visible in the United States will be on April 8, 2024, and the narrow strip will travel from Mexico and head northward to the southern part of Canada. The last picture is of the 1999 total solar eclipse, which is a composite of different exposures to capture all the details you'd be able to see with the naked eye. If you ever get a chance to travel to a total solar eclipse, take it. It really is a special event that you'll remember your entire life.